Hi everyone, welcome back to our transformations activity, lesson 9.2 on page 108. Today we are going to talk more specifically about translations, which are first of three types of transformations that we're going to talk about in this activity. So if you see on page 108, we're back to talking about the marching cougars, and we have Maria at point 2 comma 4 on our graph. So right 2 up 4, here's Maria. And the band director, Mr. Scott, tells her to move 2 yards to the right and 4 yards upfield to a new location. And Maria's new spot is now moved along with the rest of the bands. What happened here is a transformation called a translation. And on the coordinate plane, a translation is described by this function rule where we are adding or subtracting an a or a b value to our original point x comma y. So this is the function notation that we write it in. And you'll notice this looks really similar to what we talked about in the first lesson. A translation specifically is a rigid motion so that every point is going to move the same distance from the original pre-image to the new image. And that distance and direction we call the directed line segment. So you'll see kind of the example of the directed line segment here that Maria moved. Now, Maria again started at 2 comma 4 and ended at 4 comma 8 as we saw up here in the picture. So what she did is she moved to the right 2 and up 4. So we added 2 to the x value and added 4 to the y value. So if we add 2 to the x value and 4 to the y value for Joe, Alfredo, and Lahaya, we're going to get points of 5 comma 11. And then add 2 and add 4, we get 3 comma 12. And then Haya's pre-image, we're going to actually kind of have to go opposite. We started at 7, 11, and we'll have to subtract 2 and subtract 4 to get back to her starting point of 5 comma 7. Okay. Now, Mr. Scott also is going to arrange the band in a different formation. We have a rectangle here, and he directs the band member who is at 6 comma 10 to move to 4 comma 13, and the numbers are shown on the coordinate planes of the football field. So for the band to move in this translation, how much are they going to have to move if in this particular band member started at 6:10 and is now moving to 4 comma 13? Well, we changed 2 units from the x values, and the y values changed 3 units, right? We went 3 units up. So what this is showing is that, we subtracted 2 units here. So sorry. So what this shows is that we moved to the left 2 units because we decreased from 6 to 4, and then we went up 3. Okay, so if we were to now transform this picture, we're going to take every point here and we're going to move left 2 and up 1, 2, 3. And then same thing with this piece of the rectangle, up 2, up 1, 2, 3, left 2, up 1, 2, 3, and then left 2 and up 1, 2, 3. So we have our new transformation and our new spot for our x value, right, as well. And again, we could graph this a little bit cleaner over here so we don't have to see it on top of the original, that same graph showing that movement. Now to represent this, it doesn't ask for this, but in function notation, then we would say that this is x comma y. We would represent this as x minus 2 since we went to the left, and then y plus 3 because we went up. Okay. Now Maria herself is positioned at 2 comma 4, and her friend tells Maria that her new position is going to be described by this function here, since her new position is at 7 comma 0. Is her reasoning correct? Okay. Well, not precisely, right? Because if we look at this function rule, what we'd be saying is that she would need to move 3 units to the right. So if we have this function rule here and we plug in that original point, we plug in 2 and 4, really what's going to happen is Maria's new position is going to be at 5, 2. So is Maria's friend correct to say that she's going to move to 7, 0? Nope, her friend made an error. Okay, no, Maria's position will be 5, 2. So a reminder to always explain your answer if they ask you for it. All right, now we have a couple more function rule practices here on 4 and 5. And I want you to take a moment on your own to do these two problems in your own workbook. All right, now check your work. You should have had value here would be the movement to the right 4 and down 4. And then notice here, we're not actually changing our y values location at all with this triangle. They're actually not moving up or down at all, but we did have to translate this triangle to the right 3 units. All right, now we're going to kind of skip over this, although this does introduce us to the vocab word a rhombus, but we're going to deal with that much more later on in Unit 2, so we'll talk about that again there. So we'll kind of skip over that. And then just to review, which we'll talk about a little bit more in class, but the vocab on here, big thing here is that we're talking about translations, which are rigid motions, so that they're not changing the shape at all. We're just sliding is how I want you to think about the translations. It's just a slide, doesn't change the shape at all. And then the amount that it's moving in that slide is our directed line segment. All right, last but not least, we have question number 10 here that I want to talk about. And this first part says here that Mr. Scott arranges the band in the shape of a triangle, this original picture here, the pre-image of ABC. And point P is on the interior of the triangle, and he plans the transformations of the triangle at which P is mapped to P prime, P double prime, and P triple prime. Those apostrophes are what we call prime. So P prime, P double prime, P triple prime, because there's 3. Okay. So part 1 says, which of the 3 transformations are translations, and explain which ones they are. So you're gonna tell me right now which ones are the translations: P prime, P double prime, or P triple prime, and why. Well, for part A, hopefully you notice that our 2 transformations are going to be P prime and P triple prime. And the reason being, we can take our original P prime, and if we take a picture of it, here's P, the original, sorry, and shrink it back down to its normal size. And what we could do is we could take this and we can move it, so that slide it to the right so that it's the same picture as P prime, and we can slide it so that it is P triple prime. Unfortunately, P double prime is not the same picture, right? It's not just a slide. Something else would have to be applied to it, more than likely a rotation, which we're not going to talk about until lesson 9.3. Okay. Now, part B then says that Maria stands at point P of the triangle ABC, and to move to P prime, her instructions are to move to the right 8 steps. Okay. Do these instructions then apply to the rest of the band members that are also in this triangle? What do you think, and why? Well, hopefully you said that this does in fact apply to everyone, right? Because we know that if this is a translation, all right, it's going to be a rigid motion. So if she's just sliding to the right, the translations preserve the size and the shape. So everyone must move together, right? It's a beautiful thing, right? Everyone moving together. All right. So we will work more with these translations in class, but again, the big thing to know today, how to write a function rule with our translations, like so, and that these are indeed rigid motions, and we are going to keep preserving, if you look here, the length and width of a figure, the size and the shape. Thanks, everyone.